Okay, so let's look at the quadratic review part. Again, subbing in 0 is good for the y-intercept, so you can see that's way down here at a -16. Factoring is good because it gives you your roots or your x-intercept, so +8 and a -2. That's enough to kind of give me a shape, except for the vertex. I need the vertex. So I know it opens up, positive coefficient, so it's not reflected. Vertex, opposite of B, +6 over 2a. That gives you your input. You sub that into here to get the output of a -25. So now I know at 3, I'm going to have to go way down to a -25. And that gives me this point, this point. I know this point. I can reflect this over the line of symmetry to get that point, and then I have that point. That's 5 accurate points. I should be able to graph my quadratic pretty well. All right, so x-intercepts we get by factoring, subbing in 0, we got that. It's increasing, and again, remember this is only x values. So from 3 to infinity, it's increasing from -infinity to that. Absolute min or max, this is a min. Down here, that's your vertex. We have domain, we have range. That's the only time you do y values. All right, now this one. You can cheat to get it in vertex form. You can undo. So the vertex was what? 3, -25. So remember, the shifter in the x is always opposite. So -3 would give you that +3. Your y shift is what it says it is. And then if this guy has a coefficient of 1, this guy has to have coefficient 1. It's the same function. Now, if you want to complete the square, I have what? X squared minus 16, and then what? Oh, there's my -16. Okay, so what you do is, remember, you divide this by 2. Okay, so you get a -3, and then you square it. A negative times a negative gives you +9. So I'm going to add +9 here, and I have to subtract 9 here because I have to compensate. It's on the same side of the teeter-totter. You know, if I add 9, I got to subtract 9 to keep that thing balanced. All right, so this thing is going to be a perfect square. So I'm going to get that trinomial. So I get x plus 3 squared. Notice coefficient's 1. There's nothing out there. And then that minus that is a -25. So whether you complete the square or you kind of cheat a little bit, you can come up with that. Okay. All right. Number 2, this one, again, it's a quadratic. You want to set it equals 0. You want to factor, okay, or do quadratic formula, whatever. And your goal is to get those 2 key points, okay? Now, I know this is a parabola that goes through a -1/3 because you set this equal to 0. And you get, bring the 1 over, you get 3x equals -1, divide by 3, you get -1/3. Same thing here, you get a +5. So I know this is a parabola that looks like this. Now, I don't really care what the vertex is because that's not what this is asking. This is a, when is the function less than 0? Well, you're less than 0 when you're negative. So this function in a 2-dimensional graph is right there. And so it's between -3 and 5 inclusive because there. If you hate that, that's okay. You can make just a x 1-dimensional graph, just the x-axis, because that's really all you care about. You care about these key points. They can equal solid dots. And then you just do test points. So you test something over here, you test something in the middle, you test something over here, and you want it to be negative. You want the output to be negative, less than or equal 0. That happens here. That's your interval. So whichever way you do it, totally fine. All right, I'm going to pause and we'll go to the next page. Okay, so here I'm giving you the vertex and another point. Okay, so again, it's kind of like when you solve like a linear equation. With a linear equation, you might be y equals mx plus b. You're like, oh, I know input, output, I have the slope, I can solve for b. Same idea here. You know the shift, +1 there, +2 there, okay? You don't know the a, that's fine. But notice you know an input and an output. So you have your shift, and you know an input and output, you can solve for A. So I tend to go with positive input and output if I can. So I put my output there, input there, solved, I got A equals 1. So then I know that my coefficient is 1 and I don't have to write it. The good news for you is when you're done, I mean, you can sub both input outputs in, make sure they work. The other thing you can do is graph it and make sure this is the vertex, make sure it does go through this point. So there's some options to check your answer. All right, this one is where you're creating your own function, okay? So I have a fence, and they're keeping what, the two animals, I don't know. So we have maybe pigs over here, and I don't know if that's supposed to be a horse or cow. I don't know. I can't draw, but whatever. So this is, it's kind of like we have an extra little fence in there. Okay. So perimeter, I know I have 10,000 meters of fencing. It's kind of like perimeter with an extra line in there, line segment. So I have X, 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 that's 3X, and then 2Ys. I'm just adding up the sides to get perimeter, but I have that extra side. All right. Now I want to solve for Y because remember, I want to sub in for Y. All right. So my other formula is, this is a rectangle, right? So I know area equals X times Y. So I want to solve for Y so I can sub it in so I can just get X. So subtract the 3X over. Divide by 2, divide by 2. I get that. And so I can sub that in. So my X is my width. And then my length, I'm replacing it with that, okay? Now, I graphed it on my calculator or on Desmos, and I got, again, first quadrant, I only care about this little bit right here, and I get that going on right there. So the question is, what is the largest area? Okay, the input is the width, right? The X, this distance right here. The output is my answer, okay? So my answer is, about 4 million and some square meters, okay? So again, I find kind of like perimeter with a little extra side in there. Formula, just add up all the sides. I know area is X times Y or length times width, sub in, and then again, graph to find the max or the min, whatever on those. All right, I'm gonna pause and we'll go to the next question there. Okay, this one we want to graph without a calculator. Okay, so the first step is you want to factor. It's x to the 4th, so I split it into x squared. And then I have 36, so 6 and 6 would be a perfect square, so that would have to be 12, which it's not. So I did 9 and 4, both negatives, and negative times negative is positive, -9, -4 on my loopies. Okay, then these are perfect square minus perfect square. So x minus 3, x plus 3, perfect square minus perfect square, x minus 2, x plus 2. So I know that I have zeros at 3, -3, 2, -2. So I put those in here. Okay, what else do I know? Even overall power. So I know it's kind of bunny ears going up, not reflected. There's no negative there. Let's see. These are all odd powers, so they all have to go through. And so I kind of know, like, oh, it's going to do this, and oh, it's going to do that. Now, the y-intercept, if you shove in 0 or sub in 0, you can see it's way up there at 36. So I know it's going to look like that. Now, these, I don't know how deep they're going to go. If I really cared about it, I would sub in a -2.5 into that function to see where these end up. Same thing, +2.5. Sub it in to see where they go, but I don't really care that much. So I didn't worry about those too much because I care about my end behavior and I care about my x-intercepts and usually the y-intercepts sometimes too. All right, I'm going to pause. We'll go to the next one. Okay, again, my printer's a little wonky, but this is the next polynomial question. Domain is all reals and range is all reals, okay? Then I'd ask you to find the x-intercept. So again, if you mess these up, remember if it's on the x-axis, the number has to be in the x spot, right? So there's one there, -5, 0, 5, and I would accept that too. And then the y-intercept is at 0, and that's it. Okay, then it asks you for zeros and their multiplicity. Zeros, roots, x-intercept, solutions, those are all the same thing. There's one at -5, 0, 5. Now, as far as multiplicity, we don't know the overall power of this thing, so that makes it hard. So -5 right now, I would assume to the first power, but technically it could be odd, right? 1, 3, 5, 7. This guy touches, so it has to have even power. Oh, Julie, and this one touches too. I don't know. I wasn't paying attention here. Sorry. This one touches, so, maybe squared, whatever. And this one touches too. So either 2, 4, or ... So some type of even multiplicity. This would be odd multiplicity. Okay. Then it asks how many changes in direction. So 1, 2, 3, 4. So 4 humps or changes in direction. N minus 1 is 4. That means it has to be 5 or higher power. It is not reflected. Do you see how this is kind of a disco-y looking thing going kind of in the positive way? So this is going to be an odd overall power. And then end behavior is as x goes to negative infinity, right? As x goes to negative, this goes to negative. As x goes to positive, this goes to positive. Kind of that disco look. All right. Now, what is a possible function for this? Don't know the coefficient. We do know it's positive, so I'll just put a 1 there. We have x right here, and I'm going to put squared. Okay, we'll see if this works. I have x minus 5 for that guy. He touches 2, so he has to be even. And then x plus 5 has to be odd. Now, I have to check my overall power. This adds up to 5. So with my humps, that's okay. So as long as I have 5 as a power and the overall is odd, then I'm good. Okay. So if you wanted to, you might be like, well, could this be to the 4th power? Well, 4, 5, 6, 7. Overall behavior is odd. So again, disco-y, not reflected. This guy touches. So, you know, something like that would work too. But this said to do the lowest power possible. So we're going to go back to a 2 on that one. All right. I think I caught everything on that one. And again, mine printed wonky. So that's why I did that. So this is kind of all the answers I had dealing with that problem. All right, I'm going to pause and then I'll do the next one. All right, so if you look at this one, the zeros, this is just a constant that just stretches or flattens things out there. So whatever causes 0, 2, negative 4, multiplicity to the 2nd power to the 3rd. Overall power is 5, so it's kind of disco looking. So meaning as x goes to positive infinity, right? The y is going to positive infinity. As x goes towards negative infinity, the y is going to negative. Now, could this be the sketch? Now, it has 1, 2 changes in direction, which I guess this is what, 5th power, so at 4, that most humps, so this is fine. It touches there, it has an x-intercept there and an x-intercept there. The problem is that this guy's even power, so it should be touching or bouncing there. And this guy's odd power, it should be going through. So even though the end behavior is good, not what's happening there. All right, gonna pause, move on. All right, number 4, it should cross at 5, negative 3, and 2. The overall behavior is odd, so you know it's disco, right? Because it has a positive leading coefficient, it's not reflected. And so let's see. So this is one possibility. There could be others. So I went through here, came down, picked that up, and went down there. You know, I'm trying to think if there's some other options on there. It's possible. Just make sure it goes through, goes through, goes through. Well, you could have 2 bumps, actually. You could have 2 evens. And maybe make it work. So because 2 plus 2 is 4 plus 1 is 5, which is odd overall. So, you know, you might, as long as you have x-intercepts here, the overall behavior is disco, and in a positive direction, it doesn't really matter if they touch or go through because I didn't give you the multiplicity. All right, find it. Okay, if you're going to find it, remember these are opposites of what they say. Factors are opposites. I FOILed this out, got that. So first, outside, inside, last, and got that. And then I multiplied, distributed again. And again, I just distributed, so that, negative 2, negative 2, negative 2, and combine. You could do the box on that as well. So this is what it is. Now, again, you know, you could graph this to see if you were right up here. This is, again, only if you go through like I did. If you had 2 of them with even powers and 1 with an odd, obviously your graph's going to look different. But you want to pick the smallest because you don't want to multiply all that stuff out. Okay. All right. Let me go on. All right. For some reason, evidently, I did not update the number. I don't know why it's number 7, but 7 is my favorite number. But probably just a typo there. So this one you bring over, set greater than 0. So when you bring those over, there's just a 0 there. Because remember, it's always easy to compare it to the x-axis, right? Like we don't want to compare it to other stuff. The x-axis is easy. And this one I said just use graphing. So Desmos, graphing calculator, whatever you want. I just sketched it here. And notice we want to know when is that function positive or equal 0. We want it greater than or equal 0. So again, we're like, oh, okay, well that happens here and that happens there, okay, including the points. So then your interval is the negative 5/3. And again, you can get that from the calculator to 0. then you come over here 3 to infinity. So that one, I didn't want you to solve by hand. I just want you to graph it and understand that you can look at the graph and say, oh, this is when it's positive. This is when